Morning everyone, my name is Jen Heng. You can also call me Miss Jen. I'm going to teach you guys Form 4 Chapter 9, Probability of Combined Events. For this chapter, I will cover combined events, independent and dependent events, mutually and non-mutually exclusive events, and the last is application of probability of combined events. So, let's start our lesson. What is combined events? Combined events is a combination of two or more events in an outcome. So this is the formula. The total of event A multiply the total of event B. So here is a simple question. Let's get through this. One card is chosen from box J and one is from box K. So list all of the possible outcomes. There are two ways to answer this question. Let me show you the first way. The first way is in tree diagram. So first thing is we need to list out what is in the box J. So box J, we have X and Y. So how about box K? So box K, we will list out after of the first event. This is our first event, this is our second event. So how do we list out? So it's like a sub-branches. So this one is our first event, X, and then our second event is 1, 2, and 3. So same goes to alphabet Y, also like this, 1, 2, 3. And then for the outcomes, we need to list it out to the behind. Like this, x1, x2, x3, y1, y2, y3. And then for another method, is in table form. So the answer is still the same, x1, x2, x3, y1, y2, y3. And how do we list the outcome? We list the outcome by using curly braces. So we open a curly braces, list all of the outcome, and then close the curly braces. And if we are not sure the total of outcome is it correct or not, we can use this formula. So NA, what is 2? Because of we have two items for event A. We assume box J is event A, box K is event B. So box K is event B, how many items? 1, 2, 3. So we have 3 items here. 2 times 3 is equal to 6. So with this, so we count the total 1, 2, 3, 4, 5, 6. So the answer is the same. So we are doing correctly. For combined events, there are two types. There are unions and intersection. Unions, the symbol is like a U, and then there's a keyword called or. So when you see this union or this or keyword, you need to do the question by using plus sign. For intersection, the symbol is like a reverse U, and the keyword is and. We use multiplication. So unions, which means is using all of the event. For intersection, we use only the commons of event A and event B. Next, let's get through independent events and dependent events. How do we differentiate these two events? Independent events, an event does not rely on another event, outcome will not affected by each other, and there's a keyword called with replacement. For dependent events, an event relies on another event, outcome will affected by each other, and the keyword is without replacement. So in a short way is independent events, they are not connected to each other. They are not related. And for dependent events, they are related to each other. So whatever result happen in event A, it will affect the result of event B because event B is depends on event A. So that's why the outcomes will affected by each other. So let's do the exercise. A coin is tossed and the dice is rolled simultaneously, which means at the same time. The event gets picture on coin and odd number on dice. So we can see from this question, the coin gets a picture. But is it will affect dice roll and odd numbers out? No, right? So our answer will be independent events. Second question is, a child go to school by bus. What is the answer? Dependent events. We can assume that event A, the child arrived at the bus stop on time to catch the bus, and for event B, the child getting to school on time. You can see from this question, this child is going to school by bus, which means the child depend the bus by going to school. So if the child arrived at the bus stop lately, then he could not catch the bus, then he will get to school late. So that's why this one is dependent events. Question 3. Obtain a tail twice when a coin is tossed twice. What is the answer? Independent events. Yes, this is independent events because a coin tossed twice will not affect the probability when the coin is tossed second time. So it will be independent events. The last question is, obtain 2 pens of same color are taken one by one from a container which contain 4 red pens and 4 blue pens without replacement. Do you see the keyword? Without replacement automatically become dependent events. Why? Because it will affect the probability of getting the second red pen because the question is when you take one pens out, you said one by one, right? When you take one pens out and then it's without replacement, so our total of our red pens it will be 3. So that's why the probability will getting smaller and smaller and smaller. So that's why this is dependent events. So here are some calculative questions. A box contains 4 red marbles, 2 green marbles, and 7 blue marbles. 1 marble is removed from the box and then replaced. You see the keyword replace automatically become independent events. And another marble is drawn from the box. So the question is, what is the probability that the first marble is red and the second marble is green? So we can calculate the total first. So the total is 13. And then the question is, we need to find the first marble is red and then the second marble is green. So how many red marbles have? 4. And then how about green? 2. So 4 over 13. 13 is total and then green marbles has 2. So 2 over 13. So we multiply it. The answer is 8 over 169. And here is some note. Because the first marble is replaced, which means I take 1 marble, after that I put it back. So the total will not change. So that's why my second event here, it will still remain the same, 13. So how about dependent events? This is the same question for previous question, but I change the question to become not replaced. So for this not replaced, as usual, we count the total, 13, yes, and then we need the first marble is red, second marble is green, and then, okay, the difference is, do you see that? This is 12. And why is 12? Because the first marble is not replaced, which means I take 1 marble out and then I do not put inside. So that's why the total will change from 13 to 12 because I don't put inside to the box. So that's why my total will minus 1. So the answer will be 2 over 39. Next, I will explain mutually and non-mutually exclusive events. What is mutually events? Mutually events is no intersection between event A and event B. They cannot occur at the same time. The formula is event A plus event B. This one P is probability. And for non-mutually events, there has intersection between event A and event B. They can occur at the same time. But their formula will have a deduction performed here. Why? Because do you see that there has intersection because there has common, so they need to perform deduction here. You might feel confused right now, so I will explain it by using Venn diagram. It will be more clear. So I give the question is the number is from 1 until 9, and for even A, we need odd number. So what are the odd number? 1, 3, 5, 7, and 9. How about for even number? Even number are 2, 4, 6, and 8. So bear in mind, mutually events, there has no intersection here. They are independent. But for non-mutually events, for event A, we need odd number. Odd number is 1, 3, 5, 7, and 9. And for event B is prime number. Prime number we have 2, 3, 5, and 7. For non-mutually events, you need to ask yourself, is there any common? If yes, what are their common? So we need to look through this. So what are their common? We have 3, 5, and 7. So our common will be in here, the intersection. So that's why they can occur at the same time. And then for event A, 3, 5, and 7 are occupied. So the left is 1 and 9. For event B, 3, 5, and 7 are occupied. The leftover is 2. And then the others number is 4, 6, and 8. Here are a calculative question for mutually events. A bag contains 4 green, 6 red, and 8 blue marbles. One is drawn at random. What is the probability of choosing blue or green? So our total, we can calculate our total first, will be 4 plus 6 plus 8 equals to 18. So how many marbles blue have? So blue we have 8 and green we have 4. So 8 over 18, 18 is total plus 4 green marbles over 18 equals to 2 per 3. And for the second question is, what is the probability of choosing red or green? So how many red marbles have? Red marbles have 6, green marbles has 4. So we will put a plus sign here, and then the final answer will be 5 over 9. Next, non-mutually events. Find the probability of selecting a boy or a blonde hair person from 12 girls, 5 of whom have blonde hair, and 15 boys, 6 of whom have blonde hair. Which means we can do first, calculate the total. So girls we have 12 and boys we have 15. So our total will be 27. And how about blonde hair? Blonde hair we have, you see 12 girls, 5 of 12 girls will have blonde hair. So G equals to 5. And then 15 boys, 6 of them have blonde hair. So B is equal to 6. And then we calculate the total is 11. So the question asks us to selecting a boy. So we can choose the probability 15 over 27 plus, because of all, and then a blonde hair person. So our blonde hair total will be 11. But this is not our final calculation. Why? Do you notice that we have included boys here? These 15 boys is included blonde hair. Do you see the question? 15 boys, 6 of them have blonde hair. So which means these B equal to 6 are the intersection, are the common. They are repeated. So we need to perform deduction here. Minus 6 over 27. So our final answer will be 20 over 27. This is our last part. Application of probability of combined events. We combine all of the methods that we have learned before this slide and apply into every question. So for our first question, 2 coins are tossed. List all the possible outcomes. So how do we do that? We can list out T and H. Why is T and H? Because coins will have 2 faces. One is tail, one is head. But because there are 2 coins, so this is our first coin. Our second coin will be like sub-plungers. And as usual, we list the outcome TT, TH, HT, and HH. So whatever you are using, tree diagram or using table, we need to list the outcome by like this. Open curly braces, and then all of the outcome, and then close the curly braces. And then here is an extra question. Find the probability that 2 tosses are the same, which means we have 2 same places, TT and HH. So we have 2. So what is 4? What it is over 4 because we have 4 outcomes in total. So in simplified form, it will be 1 over 2. For second question, box A has 3 alphabetical cards and box B has 2 number cards. So we're still using tree diagram, and then for our box B, still using sub branches. And then we list out the outcome. So it's still the same. Open your curly braces, list all the outcome, E1, E2, A1, A2, and R1, R2, and then close your curly braces. So for 2B, we are still in the same question, but the question needs us to find the probability that a consonant and an even number are chosen. So you guys need to bear in mind the difference of vowel and consonant. Vowel is A, E, I, O, U. Consonants are all alphabets, but not including vowel. So for E, A, and R, which of it is consonant? So R is our consonant, and then an even number are chosen. 1 and 2, which is our even number. So our even number is 2. So R2 is our answer, and then he asks us to find the probability. So we need to calculate. So it's 1 over 6. Why it is 6? Because our total outcome is 6. 1, 2, 3, 4, 5, 6. And then the last question of question 2, find the probability that a consonant or an even number are chosen. You have to notice that this is all. So consonant, so for all these keywords, which means is either one is correct, then we can list the outcome. So for consonant, we have R1 and R2. Do you see that I list out R1, but you say that 1 is not even number, but you need to see the keyword because of all. So if we have this all keyword, so either 1 is correct, then we can straight away to list the outcome. And then E2, and you say E is vowel, but the question is consonant, but the beside number 2 is an even number. So we still can use E2. And then A2. A is vowel. Yes, it is vowel, but our number 2 is an even number. So these answers are correct. We need to find the probability 4 over 6, and then simplified version is 2 over 3. For question 3, Peter go to university by bus every day. The probability of raining is 0.3. If it rains, the probability of the bus being late is 0.8. If it is not raining, the probability of the bus being late is 0.2. So what is the probability of bus not being late? For this kind of question, we can use tree diagram or table form. So for this kind of question, we can list out raining and not raining. And then if it's raining, we arrive late or on time. If it's not raining, the probability of late and on time. So for this kind of question, we can write the probability direct from the question first. So for the probability of raining is 0.3. We can write 0.3 at here. And then if it rains, the probability of the bus being late is 0.8. So being late here. So here is 0.8. And then if it is not raining, so not raining here, the probability of the bus being late is 0.2. So we haven't do the question yet. We need to find all of the probability first. So for not raining, how to find? 1 minus 0.3. So we get 0.7. And then for this one, 1 minus 0.8 equals to 0.2. This also 1 minus 0.2. Then we will get 0.8. So the question is, find the probability of bus not being late. He did not ask raining or not raining. He asked bus is not being late. So only bus not being late. So we can assume raining and not raining. So our calculation will be 0.3. So not being late is on time. 0.3 multiplies 0.2. plus, for not raining, 0.7 multiply 0.8. So our final answer will be 0.62. For number question 4. Okay, you might like panic when see this kind of question. So don't panic first. We read through the question. A box contains 10 apples. 3 of them are rotten. 2 apples are selected randomly. So find the value of W, X, Y, and Z. So for value of W, how do you find it? Use 1 minus 7 per 10. We will find 3 per 10. So for X, also 1 minus 7 per 9, we will get 2 per 9. And for this one, Y is G, G, because the outcome is G, G. And for Z, it will be R and G. So this is our final value. And then for B, find the probability that a good apple and a rotten apple are chosen. So our good apple is 7 over 10. And then our rotten apple stand for rotten, 3 over 9. So we need to use plus or multiplication. But because this here have a and keyword, so we need to use multiplication. But this is not our final calculation because the question did not mention that we need to choose a good apple first and then our second choices are rotten apple. So their sequence, their order can be reversed as long as there is a good apple and a rotten apple are chosen. So for this one, we can include 3 over 10 multiplied by 7 over 9. So as long as they have a good apple, a rotten apple inside of this combination, then this is our final calculation. Our final answer is 7 over 15. For C, find the probability that at least one good apple is chosen. So minimum one good apple is chosen. So GG, so there's a one apple, good apple is chosen. GR can be applied to this and this one apple. Yes, can. How about RG? This also can because there is at least one good apple. How about RR? Is it applicable? No, because there is no good apple here. So our calculation will be 7 over 10 multiply 6 over 9. For this one, GR, 7 over 10 multiply 3 over 9. And then for this one, RG, 3 over 10 multiplied by 7 over 9. So we have to plus addition performed here, and then we will get our final answer, which is 14 over 15. For question 5. There are 5 red balls, 7 blue balls, and 2 green balls in a bag. One bag is picked from the bag. Calculate the probability of a red or a blue ball being picked. So when you see this all keyword, so our question need to be plus sign, need to have a plus sign, we need to perform addition here. So before we do that, we can calculate our total first. So our total, 5 plus 7 plus 2 equal to 14. So we can calculate the probability right now. So how many red balls have? Red balls we have 5, 5 over 14, and that blue balls is 7. And then here is a keyword or, so that's why here is a plus sign, equal to 12 over 14. And then we simplify 6 over 7. And then next, a bag contains cards number from 1 to 14. One card is drawn at random. Find the probability of selecting a prime number or a multiple of 4. So before we do that, we can list out all of the prime number first. 2, 3, 5, 7, 11, and 13. How about for multiple of 4? 4, 8, and 12. So for this question, I show you the answer first. 6 over 14. Why is 6? Because there are 6 in total. And then 3 is there are 3 in total. And then here is 14 because our numbers have 14 in total. and there is a keyword or keyword. That's why we have a addition plus sign here. So we perform addition here and we will get 9 over 14. So next, it's still the same question, but I change multiple of 2 or a multiple of 3. So multiple of 2 is 2, 4, 6, 8, 10, 12, and 14. And for multiple of 3, 3, 6, 9, and 12. So there is still the same way to do the question with the previous question. So 7 over 14, because here is 7 in total. 1, 2, 3, 4, 5, 6, 7. And plus, because of all keyword, and 4 over 14 because here have 4 in total. So you need to ask if there any common here. Do you see any common here? If yes, what are the common? So what are the common? 6 and 12. So there are 2 common. So we need to minus 2 over 14. Then it will equals to 9 over 14. So that's all for our question. And this is our summary. Bear in mind that and keyword we use multiplication. All keyword we use addition. For independence event, they do not affect each other. For dependence event have the keyword without replacement or not replace. And for mutually exclusive event do not have intersection, which means there are no common between the events. And for non-mutually exclusive events, they do have intersection and they can occur at the same time. So that's all for this chapter. And thank you for listening to the end. Like, share, and subscribe to our YouTube channel. And we will see you guys for next chapter.